All right, guys, so today we are starting Chapter 1, Notes for Geometry. So the first section of geometry. Now, there's many different types of geometry that there is actually covering. We're not going to be covering all of these here. Now, some of the topics that we will be covering is something called Euclidean geometry. Those are the types of math or geometry that we will cover. So when we look at all the different types of Euclidean geometry, we have these here. Now, we're not going to be covering Hilbert's axions, but we will cover points and lines, parallel lines, angles, congruency, some of this here. So we'll be covering some of these here. We won't be covering all of them because shear mapping we won't be covering. Some of the others we won't be covering, but we will be covering some of these. All right? I mean, not too bad, yes? All of these here are other types of Euclidean geometry. Because we can talk about kites. We will talk about kites. We won't talk about cyclic quadrilaterals. But there is also three-dimensional geometry. Like all of these here are different types of math. There's even more. And again, I'm showing you not to scare y'all, but to really kind of for y'all to understand geometry and mathematics as a whole is vast. There's so many different things that it covers and talks about. And then we also have something called non-Euclidean geometry. And the one big thing that differs between Euclidean geometry and non-Euclidean geometry is Euclidean's proposition number 5, which states, hold on. Number 5, which states that through given a point, and a line, given a point and a line, there's exactly one line through that point that is parallel to the given line. If that is true, then it's going to be considered Euclidean geometry. So if I draw a point and a line, then there's exactly one line through that point that will be parallel to that given line. If it does not hold true, it's considered non-Euclidean geometry. So spherical geometry. So geometry on a sphere does not hold true for this. Because on a sphere, this is not going to be necessarily true. All right? So there are different forms of geometry. But we won't cover it in here. Right, so that there. Because we won't cover a lot of the non-Euclidean geometries, and there's a lot of different ones that are actually quite interesting. Some of the topology that I find quite interesting. Because one of them is talking about if we take a figure, and as long as we don't break any line segments, so anything that's not already connected, we don't break it, we can move and change things and rearrange it. So this here is an R, and we consider that to be a little bit of a line, yes? Well, if I stretch that out, stretch out the middle line, because it says nothing about length, we can turn it into an A. Because again, as long as we don't break anything, we can change it. So a lot of stuff you can do with this here, and different things. I find it interesting. But if you don't find it interesting, that's fine, because there's even more. Numerical geometry and various geometric algorithms. There are so many different types of math to delve into, but we're only going to look at a certain amount. All right. Now, the first thing we're going to look at is something called undefined terms. Now, that was on the note sheet, yes? Or on the vocab sheet, undefined terms. Were y'all able to figure out what they were? Okay, that's fine. The first undefined term is point. A point has no dimension. A point has no dimension. A dot represents a point. So this is one of our first undefined terms. A point has no dimensions. It's kind of representing a location. Now, can anyone make a point on their paper? Right? So what? Like that? Yes? Well, that automatically fails the definition. Because what does the definition say? A point is what? It has no dimensions. I can take a ruler and measure that, yes? As soon as we put pen to paper, make a point, we give it dimension. But by definition, a point has no dimension. That's why this is one of the undefined terms. Because we understand what a point is, we understand that a dot represents a point, but realistically, we cannot make a point. It's an understanding, a concept that we have, but we cannot actually make it. That is why it's classified as technically an undefined term. It's a concept that we can think of and we understand, but we can't actually make. Does that make sense? Now, the next one is a line. Now, this might seem a little weird. Why is a line considered to be undefined? A line has one dimension. You don't have to write all this down as long as you get an understanding of what we're talking about. Because again, most of this you wrote down yesterday. A line has one dimension. It is represented by a line with two arrowheads, but it extends without end. So realistically, can we draw a line? No, because it's going to keep going on forever and ever. No matter how long I extend it out in both directions, it will continue to extend without end. So just like a point, I can't create a point. I can't really fully create a line. But we do draw arrows with an understanding that it will continue without end. Now, when we name a line, there are several ways that we name it, and we use 2 points. The way we name a line is we use 2 points on the line. So here, the 2 points on the line are A and B. So we can say AB, and we draw a line above it. So whenever we name a line, we use 2 points. And we could also name it BA. So AB or BA would be used to name this line. Now, sometimes you can see this here, and I think it's on your notes. No, it's not. They will have a little letter at the end of the line, and it's always going to be in lowercase. And we could use it to name the line. So we can say line L. And if we're using the letter at the end of the line, we need to put line in front of it. We need to describe what it is. Any questions on this here so far? Now, this seems a little tedious for us doing this here, but this notation is used to describe the line. And even without the picture, we know what we're talking about. Because the symbol above it tells us that this is a line, and it's going through the points B and A. Now, I will signify this now and tell y'all now, whenever we name a line, it's only 2 points. 2 points names a line. I really hope this doesn't happen, but I have a feeling there's probably at least one, because there's at least one every year, that's going to put 3 points down. We only use 2 points to name a line. All right? Not 3. Now we can look at the last one, which is a plane. A plane has 2 dimensions. It is represented by a shape that looks like a floor or wall, but it extends without end. So just like a line, a plane is extended without end. Now, if we name a plane, so are there any questions about planes or what they are? Because we got the definition yesterday, yes? Now, the way that we name a plane is we use 3 letters that are on the plane. 3 letters that are on the plane. So here we can say plane ABC. Or I can say plane BCA. Or plane ACB. Because I can do any iteration of these 3 letters to name the plane. But they cannot be on the same line. They cannot be collinear. We can use any three letters on the plane as long as they are not collinear. They make a straight line. They're on the same line. Does that make sense? And we'll see an example of one here in a minute. Any questions on this so far before we hit the last term on the page? Does anybody remember what collinear is? Collinear points. Points that are on the same line. Coplanar are points that are on the same plane. I find remembering collinear not too bad or not too hard to remember. Because what's in the middle of this? Line. Same line. Collinear. And you will find a lot of times in mathematics, they will name it exactly what it is. And that's true for science too. Science and math are pretty go hand in hand. They really like naming things the exact thing that they are. Coplanar. Planar, plane, on the same plane. Points that are on the same plane are coplanar. Points that are on the same line are collinear. Questions on this here? We good with this here so far? Yep, we're gonna have to work on these slides. That's fine. Naming points, lines, and planes. So this is on the bottom of the first sheet. This is supposed to have a line above it. So, question A. Give two other names for line PQ. So we'll do that first. Yes? So we'd say QP, and we need to draw a line above it. I will count off, especially on the test, if you do not include that line. Yes. Because we will get to one, if y'all remember in the notes, they had a ray. A ray is a line that has one endpoint and continues indefinitely in another direction. So if we're going to name a ray, it would only have one arrow. Yeah, so we can be able to tell the difference between them. And they do this especially if you're not given the picture, because a lot of times in higher level or kind of pure mathematics, when we're talking geometrically and proofs, they don't always include a picture for you to look at. So using this notation and this terminology, they can describe it and we can talk about it without actually having a picture to represent it. We know what we're referring to. So QP is another way to name it. We also have the little N up at the top near the arrow. So what we can call it is line N. Any other questions on part A so far? Because we still got one more part to it. Yes? Because what else do we need to do? We need to also name plane R. And I did leave that off. Now, if you notice in this here, there's an R in the corner. So, almost. And that's because I didn't explain it. So R is used to name the plane itself. So like N names that line, R names the plane. It's not attached to a point. So what we can do, so I'll put this down here so I have room. So we can't use R, but plane, we can use any of the other letters. So these here. So V, you're good. S and T. So M is being used to name the other line because it's lowercase. A lot of the points, almost all the points are going to be used, are going to be uppercase. R, whenever it's over by itself in a corner, most likely it's being used to name the plane. On a test, if you're not sure, ask, because I will clarify those if it's not clear. Okay? So if you're not clear, is R actually a point, part of the plane, or is it part of the line? Ask, I will clarify that for you. Okay? Yeah, actually we can. So we can use P. What else can we use with it? We couldn't use M because M is actually just naming the whole line. That whole line is line M. So we need two other letters. We can use P. What else can we use? V and T. PVT. Now with this one here, this plane will have to use point V in every way we name it. Because again, when we name a plane, we need 3 points that cannot all be on the same line. So if I use P, V, then I can use S, PVT. If I use TS, I can't use P because those three are on the same line. Now it might be very tempting to use Q, but where's Q relative to that plane? It's outside, it's above it. So interestingly enough, that actually leads us to point B. Name 3 points that are collinear. I think I already stated it, which are? Yes, S, P, and T. S, P, and T are collinear. Name 4 points that are coplanar. Well, we know what 3 of them are. SPT, but our other one is V. Coplanar are on the same plane, collinear are on the same line. Questions on this here? Are you ready for the next one? Use the diagram in example 1. So this diagram here. You have 2 other names for line ST, and then we want to name a point that is not coplanar to points QST. So 2 other names for line ST. Yeah. TS would work. What else would work? Line M. And whenever we use the lowercase letter at one of the 2 arrows, we want to put line with it just to specify that we are talking about a line. What's another one? Because we have a few. PT. Or we could have let's see here. 1, 2, 3, 4, 5. I think there's one more. STTS, TP. Yep, that's it. Because since there's 3 points, there should be 6 plus line M, so 7. So with lines, because again, a line extends without end. So no matter which points we use, it will still extend through the other one. It extends indefinitely through 2 points. Questions on this end? Or questions on this here? Okay. So what's the 1 point that's not coplanar to QS and T? Almost, because R does name the plane. Q. Or we can say point Q. So anything on this here would be coplanar. Now R named the plane, M named the line. So our 3 that we're looking at are T, P, S, and V. Those would be coplanar. They'd be on the same plane. So the only one that's not on the plane is Q up here. Questions on this here? Okay, now we're going to get into some actual terms that we can kind of make or get close to it. One of them, the first one, is a segment. Now, a segment is like a line, but a segment has two endpoints. A segment has two definite endpoints. So if you're going to put something out, I'd say a segment is a line that has two endpoints. It has a start and it has an end. So when we name a line segment, so AB, I'm going to put a line segment above it. I'm going to put a line without any arrows because that's what a line segment is. So I could name this AB or BA. These are naming the same line, yes? Naming the same line segment. Okay. This isn't in your notes, but I'm just going to put an example. Let's say A, B, C. Now, is AB, line segment AB, going to be the same as BC? Are these the same line segment? Does it look like they could? I mean, they could be, right? But do I know the length from A to B? Do I know the length from B to C? No. So am I able to say that they're congruent? No. So these are not the same. All right? So we can't, and AC is definitely not going to be the same. These are all different segments. So when it's asking to name or rename a segment, we need to be careful that we don't try to use these as the same segment. Now, we will get to a point where we are able to say that two segments are congruent or not based off properties. But until we know that proof or have shown that that proof is true, we cannot use it or assume that it is. Questions on line segments? Not too bad. Mainly what we're learning today is just different types of geometry and how to name them. Now, ray. The ray, AB, is written as AB with an arrow over it, consisting of an endpoint A and all points on the line AB that lie on the side of AB. So rays have an endpoint and continue indefinitely in one direction. Unlike one direction. So I think I made that joke yesterday, didn't I? Or it must have been a different hour. So a ray has an endpoint and continues on in one direction. That's what we call a ray. Now there's different things with rays, so this is a side note. Again, this is showing my humor. Very punny, very, I don't know, witty sometimes. But I've annoyed a few people here and there. In college, I had a friend named Ray. He got tired of my jokes. In calculus, we covered that light rays, if you've covered in science, light rays will bend as they approach large gravitational bodies. I told him, or I saw him one day, hey, Ray, you look a little bent, because the Earth is a large gravitational body. So, at the school or college that we went to, they would put up a big Christmas tree and then decorate it. So they'd get a real tree, they'd put it up in the dorm, and then decorate it. The tree, again, the floor, it was a 3-story dormitory and then an open atrium for all 3 floors. The tree every year would hit the ceiling. So it was a 3-story tree. So we're talking about like 36, 40 feet. My friend Ray was helping pull the tree up to stand it upright. I told him, hey, don't go too far because you can't come back. Has one endpoint and continues indefinitely in one direction. Yeah, no, that's what he was like after about 2 weeks. He was tired of the jokes. And the sad thing is I was coming up with a new one every so often. So that's my humor. But again, with rays, now one of the big things with this, whichever one the endpoint's on is the side without the arrow. All right? So the side that does not have the arrow is going to be our endpoint.
Do you want us to dot it like you did for the endpoint?
No, you don't have to dot it, but it's normal the way we normally write it. We put the endpoint to the left. So even though, as we see for the second one here, the endpoint is on the right, we still want to write the endpoint on the left so we know where it starts and where it goes. And these two here are two completely different rays. Because again, A is the endpoint here, B is the endpoint here. So they differ. But opposite rays make a line. Realistically, that's what opposite rays do. Two rays are considered opposite rays if they share a common endpoint and go in opposite directions. They make a line. Opposite rays make a line. Questions on this here? We good with everything so far? All right, so let's look at these two with rays, line segments, and opposite rays. So can anybody give me another name for line segment GH? Yep. That's the only other one. The only way that we can really have two names for line segments is if I say name the line segment, I don't actually give you one, then you could have GHHG. Name all rays with endpoint J. 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 And when we do this here, we start over the J and draw the arrow over E. So what's another one? JF, yes, JG, and JH. That was convenient. Because the next part we want to do is, I'm going to circle them because we want to see which ones are the opposite rays. So JE, and which other one would be opposite rays? And the other set is? Yep, those are the opposite rays because they make a straight line. Questions on this here? So, how do we feel about naming rays and line segments? Not too bad. So, how about KL? Give another name for KL. All right. Are KP and PK the same ray? Are KP and PK the same ray? So KP would be going this way. PK, so this is, no, they're not. They're going in opposite directions. Okay, nope. Let's look at the next one. Are NP and NM the same ray? So what's NP? NP, yes, and we continue this way. Then the other one is N, so are these the same ray?
They're on the same line, but they wouldn't be the same ray because they've got opposite ways.
It would be yes. Because where's the endpoint for both NM and NP? So NP would go through P and continue through M. Because again, a ray has a single endpoint and continues indefinitely in one direction. So in P and NM, because it goes through P, it'll still go through M. For NM, it goes through P to get to M and continues on. So if we want more than one way to name a ray, we need more than one point in the direction in which it's headed. Any questions on any of this here? All right. I think it's time for some, almost, we got another minute. So we can finish this right here for y'all. Intersection. Two or more geometric figures intersect when they have one or more points in common. So we consider two things to intersect when they have one or more points in common. They share points. Intersection of the figures is when the set of points have a figure, when the set of points figures have in common. So the two lines that intersect, they intersect at a point. That would be a point of intersection. Now, the two planes there intersect at a line. So that would be their line of intersection. This is the intersection of figures. Intersect in a line or plane, because we can have them share a same plane, or a point. Any questions on any of this here? Okay. It is 3 for those that are headed out. I will post the assignment up later, all right? Because, yes. This is the last thing we're going to do. This is probably the easiest thing we will do today. It's easier than what you think. So I'm going to let y'all try this here. So the first one is sketch a plane and a line that is in the plane. Give it a shot. Yeah, draw what you think. And then we'll sketch a plane and a line that is in the plane. No, you don't have to label it. Almost, that's very close. Exactly, the first part. So, I think most of y'all got something down, yes? So what do we need first?
Plane.
We need a plane. Well, apparently it won't let me draw. A plane. And then what? A that is...
Also, it can't like go out of bounds.
No. Because if it did, that means it would not be in the plane. It would actually intersect the plane. Sketch a plane and a line that's in the plane. Yeah, it could be in any direction. I just picked one. Because it didn't have to be in this way. Because, I mean, it could go this way, over here, over here. I mean, any way we draw a line in the plane, it still works. Sketch a plane and a line that does not intersect the plane. Almost, but a line that does not. Right? Because let's see, what's the definition of intersect? Intersects two or more geometric figures intersect when they have one or more points in.
Oh, I think. I think I understood it. I'm not for sure. Not for sure. I am for sure I did not understood that.
I know.
I had it at least because I lost it.
So where would we draw the line?
But like,
Why?
That does not intersect. So if it intersects, it shares points.
if it's inside it, it's not intersecting anyways, right?
Because a line shares points. Because if it's in here, all the points that are on the line
Oh.
are also shared on the plane.
You know what?
And you couldn't do a segment either. Because it said
Yeah, because if it said segment, draw a segment that's not on the plane.
So how long is the assignment?
so this paper.
So we do, it would be this here. But we'll do one more of these here. This here is the last one we'll do today. We'll finish this up tomorrow because I do want to look at the other ones. So the last one, sketch a plane and a line that intersects the plane at a point. We do not. So the ... is signifying that it's behind the paper. Yep. So I can actually do, so yeah, essentially this is all it's saying because it intersects the line that does not have a dimension of width. Yep, and the point at which it intersects is the point of intersection. And that's it.